CLR bandpass filter. Our task is to find a bandwidth for the given CL and variable resistance. Okay, so at first we set R variable as the value of this resistance. Then we set parameter R var and arbitrary value here. Then in analysis setup AC sweep, and let us select from 10 Hz to 10 kHz with 100 Hz points per decade. And what regards parametric analysis, variable resistance, a global parameter decade sweep type, and start value 100.1k with only two points per decade. It is enough. We save these values and we start simulation. After completing simulation, we may add plots to the probe window. And below we have a plot of a gain as a function of frequency for these three values of resistance, and above we have a bandwidth as a function of resistance. This is a linear function, then obviously 3 points or even 2 points are enough to draw such a line. For these three frequencies we have the following bandwidth. The greater is R, the greater is the bandwidth. It is a linear function, as I have said. Okay, now let us very briefly repeat all these live. This is link to already stored in the computer memory circuit diagram, variable resistance, our parameters is R var. Well, these values are arbitrary. Setting of analysis setup AC sweep from 10 Hz to 100 kHz with 100 points per decade. And what regards parametric analysis, variable parameter R var, a global parameter decade sweep type from 100 to 1k with only 2 points per decade. Okay. These data have been stored already in computer memory. Now start simulation. Simulation started. We are taking all three values of resistance and we have a black window. So at first let me add trace and gain, which is V of node number 3. So this is gain for three different values of the resistance. Now let me add another plot to this window. This will be a performance analysis now. Performance analysis, so we have resistance on horizontal axis and trace, add trace, and we have a bandwidth at the top, a goal function, a bandwidth. Okay, the bandwidth of voltage in node number 3 and 3 dB. Okay, and this is the bandwidth. It is a linear function. Okay, that way we have completed this exemplary problem.